I'm Jim Anderton, and this is the Industry Insights and Trends podcast. On this show, we'll explore the length and breadth of 21st century engineering, from civil engineering mega projects to innovation at the quantum level. We speak with subject matter experts and industry watchers from every sector of the engineering discipline. You know, computer-aided manufacturing has been around in one form or another since the 1960s, but the ability to just program CNC equipment, well, that was just the beginning. Today, manufacturers are expected to aggregate, integrate, and act on vast amounts of data generated on the shop floor, as well as from multiple departments within the organization and on down the supply chain. Low-cost general-purpose robotics is currently regarded as sort of the first step in the evolution of the digital factory, but there are going to be risks and challenges along the way and a lot of complexity. And in this new year of tariffs, the stakes have never been higher. I've been joined by Mastercam President Russ Bukowski. And Russ, you are part of an organization, of course, has been around a long time and has been involved in the digitization of the factory. We're in terra incognita now. We're looking at a tariff world where there's an expectation that manufacturing is going to reshore in America on steroids. Are you seeing any inklings of that yet at your end?
Yeah, well, Jim, first of all, thanks for having me today. Certainly, we're seeing a lot of changes in the U.S. manufacturing landscape today. Tariffs are playing a big part. A lot of the raw materials that the Mastercam customers use are imported goods, especially aluminum and steel, which are very, very popular raw materials amongst our customers. And the tariffs, especially in Canada and Mexico, are impacting the ability for those vendors to be able to bring in materials at a reasonable price point. So what Mastercam is doing to help support manufacturing in the U.S. With the onshoring is we're working with a government program called ACE, which is it's a across the U.S. program that provides training in manufacturing, because I'm assuming at some point we're also going to have to discuss the skills gap, which is also impacting the manufacturing industry in the U.S. So Mastercam is working to develop these programs that will help with the rebuilding of manufacturing in the U.S., the onshoring of jobs, and it really starts at the education level. It really starts at focusing on how can we provide more information, more resources into educational institutions so they can be ready for when the jobs start happening in the U.S. from, what we're seeing with the tariff impacts and things like that.
Yeah. Russ, inevitably, the conversation was going to move toward the skills gap because everyone is talking about it. I talked to, large shops and small, across the country, and there's no doubt about it. It is a factor. It was a factor before tariffs. There were presumably demographic reasons for that down there. What are you hearing sort of on the street as you talk to operations across the country there? Is there a sense that they've got a grip on this thing, or is there a concern about filling those orders?
Yeah, there's certainly a growing concern, a continued growing concern. As you mentioned, Jim, this is not a new problem. This is something that's been around at least for a decade, maybe close to 2 decades at this point. And one of the big challenges that we have, especially in the U.S., is getting young people interested in manufacturing. There's still a perception of manufacturing being, a dirty job, a job that is, not a white collar job. And today that couldn't be further from the truth, right? And so when we talk to a lot of customers, a lot of what they're trying to do is shift perception, right? And they actually are bringing some of the local universities into their manufacturing facilities to showcase just what manufacturing is in 2025, because a lot of it is very much a white collar job, especially when you talk in the CAD/CAM space. A lot of the time that people are spent, it's in the office. It's doing the design work, working with mechanical engineers. It's doing the CNC programming, working with your shop floor people. And so really a lot of what manufacturers are doing today is they're helping shift the perception around what manufacturing is. It's not the assembly line work that people imagine from, the mid-1900s.
Yeah, it's amazing how much B-roll I see on popular media that'll show a 1960s image of an auto plant with sort of sparks flying, or a steel mill, things like that. But yeah, I've seen tool and die makers that work in shirt sleeve environments in a comfortable office because they're doing everything remotely anyway. And if you're going to work in G code, here's a question for you: is simulation a part of this? I mean, we're now in a world now where you really don't have to clamp in a block of utility grade aluminum and then validate your tool paths anymore, basically. So now if you can simulate and validate without actually having to go to the shop floor, is that one way that you can sort of make this more of a white collar industry?
Absolutely. And just going back to tariffs real quick, that's also a way that Mastercam and some of our key partners like Vericut are providing utilities to some of the customers to ensure that they reduce the amount of waste in their process. With the tariffs impacting the raw goods, you don't want to waste any material on the shop floor. So whether it's verification or full simulation, where you're looking at the entire machine kinematic and making sure that there are no gouges and that the part's going to run smoothly and cleanly, that's a huge advantage for a lot of businesses these days. And a lot of businesses see that simulation, whether they're using the simulation in the CAM system or they're using an independent verification system, they see that as an investment in their capabilities and ensuring the quality and inspection. We're also seeing a lot more quality control in process using probing solutions like Mastercam Probing, which is a brand new product from Mastercam that allows users to actually monitor the parts as they're being produced on the CNC machines, so they don't have to wait for final QC and inspection at the end of the process. They can actually QC that along the way.
Russ, with the virtualization of this process on the test and validation side with simulation, I've heard sort of the metaphors like video game. It's like a video game, pop up. And I'm wondering at this point if we're breaking down that old paradigm, which is if you want to work in this industry, you have to come with a background in that industry. Do you need to be a machinist now to actually, for example, operate a CNC machine tool? Do you need to be a manufacturing engineer necessarily, or can you come from the coding side? Or come from someone with a computer background and integrate well?
Yeah, it's funny, Jim. Whenever I visit a customer, I always look for one indicator of the CNC programmer's background, and it's whether they have a copy of the machinist handbook on their desk or not. And that very clearly indicates to me where they came from. Did they come from the manufacturing engineering background, or did they come more from the high tech coding side? And we see a good mix of people coming from still both areas of industry. We are seeing more and more young people coming in that want to be involved in engineering and manufacturing, but they don't want to have the machine shop floor experience. So they come in more from that high tech side. Now, what they're looking for in a CAD CAM system is they're looking for more automation, more AI that can bring that historical knowledge, that intelligence from the shop floor into the application for them. They're focused on how do I create my idea? How do I get that out into the real world? They're not focused on speeds and feeds and manufacturing data. They're more focused on how do I make this idea a reality?
Yeah. Now it's funny you mentioned, and hold that thought about AI, because there's no way you can have a conversation about anything anymore without talking about AI at some point. We talked about getting young people interested, getting young people involved in this thing. If it is code heavy, you would think that would have a natural attraction to a certain subset of young people that just are involved in this, that are profoundly interested in it. But here's something I've noticed, which is more and more I'm hearing that firms are starting to outsource more and more of the design as well as the manufacturing task down up the supply chain. So they want their suppliers now to not just supply them with a block of raw material. We'd like you to fly cut it. We'd like you to grind it to a certain dimension. And then we want to sort of process it. So they want to sort of become, in the ultimate example, assemblers of things that they outsource completely. But in terms of semi-finished goods, we're seeing that too. And that kind of changes the engineering function from one of management and monitoring as much as actually doing. Is that a phenomenon you think that we're going to see accelerate?
Yeah, absolutely, Jim. And something that we see not just at Mastercam, but across the Sandvik ecosystem is the need to partner with solutions that provide that production lifecycle management from A to Z for these organizations, because you're right. They are much more interested in how can they produce that finished good as inexpensively and as quickly as possible. And usually by pushing things up the manufacturing chain, they're able to say, well, hey, give us the final material that we can assemble for this component that we're making, and they'll pay that extra 10-20% to receive those goods, because they know they're having a hard time finding the labor to be able to do those tasks in-house anyway. And we are seeing some consolidation in the manufacturing industry, especially in the US, where we see tier 2, tier 3 suppliers buying up their suppliers underneath them to create these integrated services and these kind of turnkey solutions inside of manufacturing.
Yeah. We've seen, I guess, a most famous example of Boeing reacquiring a major supplier that they had spun off as a way of sort of getting a handle on quality control, as one way to do that. So is there a sweet spot, do you think, between outsourcing quality critical or task critical functions to the supply chain versus trying to aggregate it all and keep it all in-house? Henry Ford wanted to do everything, including the nuts and bolts. And then it became fashionable to outsource everything there. Is there a sort of happy middle?
Yeah, I believe there absolutely is a happy medium there that you need to strike inside of manufacturing, and a lot of it's going to come down to quantity. You know, the shops that are doing lights out manufacturing that are going to run things overnight, they're more likely to outsource some of those materials because they have long production cycles. They have a lot of parts that they have to move through the production cycle. The job shops, the mold and die shops, they're going to do as much as they can internally because they're usually smaller batch, especially mold and die, where, you know, they may be cutting a mold that might take, you know, multiple days, if not over a week to cut on a machine. You know, that level of quality, they don't want to trust out of house. So they want to make sure that they do as much as they possibly can in house, because the quality of the mold is so important to them. So, you know, depending on where you are in that manufacturing food chain, yeah, there's definitely a balance to be struck. We find that the lights out manufacturing facilities much more likely to outsource, you know, lower tier components, maybe not components that are needed for rigidity or anything like that within the final assembly. Whereas you go into the smaller mold and die and job shops, they're much more likely to try to take on as much of the quality control aspects as possible inside of their building.
Yeah. Now you mentioned those mold and die shops, and one phenomenon that I'm hearing is that as it becomes a higher mix, lower volume kind of world, everyone wants everything customized. Is those tool and die shops that were using spotting presses, or they had a single injection molding machine to validate the tool before they deliver it, are starting to think about, well, you know what, we could also do a production run on this equipment, because if the customer only wants 1,200 parts at that point, we've got the tool, we just built the tool, we just validated the tool, let's just run them. Do you think there's a future for that?
Yeah, you know, it's difficult to say on that end. I think with anything, it comes down to, you know, the quantity and the break points on the pricing for these things. And you're absolutely right. In some cases, it may be easier to manufacture these things. We still see a lot of customers that are doing raw casts that are then doing finished machining using the CAM system. So there's still a variety of methods that businesses are taking. At the end of the day, it's going to come down to dollars and cents for these businesses. What's going to be the most cost efficient? What's going to be the most profitable for them? And certainly when you start to think about the impact of the tariffs, it might shift some things more to doing this internally inside of the US to reduce that cost profile to maximize their profit margin.
Yeah, yeah. You know, I promise we come back to AI, and we just have to. It's just such a hot topic right now. With today's technology now, especially some of these AI-enabled systems, you can reverse engineer almost anything. You could open a mold cavity, blue light scan the inside of that thing, digitize it, essentially press a button, and someone offshore could copycat a mold insert, you know, almost at the drop of a hat. Is there a way to protect this? Is there, with the ability of AI to look at anything, process anything, emulate almost anything, is there an IP angle to this? Is this something where we're going to turn around and think less about whether or not I own the tool and more about whether I own the IP to the tool?
Yeah, I believe we will, and you're already seeing this maybe in the home hobbyist market, or, you know, like the maker spaces, where you have people that are coming up with these great 3D models for 3D printing, additive manufacturing, and you'll see people selling the raw models online, the step files, the STL files. Once you do that, your IP can be made anywhere around the world for, you know, pennies on what you're doing it for, and so, you know, there's some cases where people are putting their IP out there because they know it's inevitable. They know that somebody's going to reverse engineer this thing, and so let's get ahead of it. Now, when you get into the, you know, the professional, the industrial, and the enterprise level, it's much more important to protect that IP, and this is where strong governance of AIs really comes into play. And there are a lot of considerations with AI right now. Who really owns the work that is being created by the AI? You could say the same thing with reverse engineering. Who really owns the IP of something that's been reverse engineered, right? So this is something that's bigger than manufacturing. This is something that goes into, you know, the audio recording industry, the television industry, the video game industry, anywhere where you have talent that can be reproduced using AI. Who really owns that IP at the end of the day? That's a big ethical dilemma that we're facing in the next 5 to 7 years inside of manufacturing, as AI begins to become more and more of a staple inside the manufacturing industry.
Yeah. Russ, if an end user, if the shop is using your technology or similar technology from your competitors, who owns the G code? Is that in fact considered IP currently?
Yeah. So I can't speak for our competitors, but for Mastercam, our customers own their G code. Everything is processed locally on their computer systems or their networks. We don't collect the G code. We don't inspect the G code at Mastercam. We make sure that that IP lives with that customer. And there's a lot of reasons for that. Certainly the legality aspect of IP ownership is really important in making sure they have that. But also a lot of the customers that we work with, they have, ISO processes, or they have, strict requirements in their shops, and they need to make sure that everything is controlled with a fine-tooth comb. And so making sure that they have not just the origin, the source files of those CAM programs, but the G code inside of whatever data repository they're using, it's really important that they own that. So Mastercam makes sure that our customers, they retain the IP rights to what they produce with Mastercam.
It's a legal and regulatory framework that overhangs a lot of industries, a lot of sectors in manufacturing. Aerospace comes to mind. Automotive is there. We're looking at a sea change in government now that includes not just tariffs, but also a potential wave of deregulation, which is much being talked about at this point. What's your opinion on that? Do you think that's going to sort of take the handcuffs off these, especially the SMEs, the small and medium-sized shops, or is the period of flux while you sort the thing out going to be an inhibiting factor?
Yeah, difficult to say, right? I wish I had a crystal ball that would tell me, is deregulation in manufacturing a good or bad? It might have short-term benefits. It might have long-term consequences. We really don't know. But what we do know is we can look back historically, and we can look at, especially when it comes to the legality of things produced with AI, we can look at the patent industry and see, what were the impacts before manufacturing patents existed? How quickly did things get reproduced? How quickly did things move overseas in the manufacturing business, and then potentially take jobs away from people inside of the US or wherever the source country is? And I think we're facing similar challenges with AI now. So looking back historically at what was put in place in the early manufacturing days with the patent process probably needs to be updated and evaluated for what do we do now with AI, and what's the process for, can you even patent something that's been produced with AI? And again, who owns that if you can? So deregulation, it might be good in the short term because it will allow organizations to move very quickly, but they could very quickly find the risk of their IP getting out there in the world, being produced for, pennies on the dollar, a large impact long-term to the sustainability of their business.
Yeah. Russ, a final question. Is the manufacturing engineer going to disappear? Are we looking at a world of technology now where basically someone in sales is going to have an idea for a product they can sell, and then from that point on, it's hands off and it just like appears off the end of the assembly line?
Yeah, that's kind of been the question for I think a few decades now in manufacturing, and I'll say it goes back and started with additive. Everybody was afraid that the CNC operator, the CNC programmer was going to go away because additive came onto the street, and additive's been around for decades now, and it hasn't fully replaced the CNC machinist, the CNC programmer, and with good reason. Now you have to look at those technologies as being supportive of each other, right? It's, in our business, we see a lot of customers who are using additive manufacturing. They're doing the reverse engineer for like a break fix on, a turbine or something like that. They'll lay down the material with the additive machine, but they still need to come in and do the fine finishing with the CNC machine. I think with AI, the position we're in today with AI is not mature enough to replace true manufacturing intelligence, people with experience that have been in the manufacturing world, that have been in the machine shop. Right now, AI is more of an assistant. It's something that will help somebody who's already competent move a little bit faster, but it's not something that is going to prevent somebody from getting into manufacturing, because you can't have zero experience to go run a machine based on what the AI is telling you today. In 10 years, as the AIs improve, we'll have to wait and see what comes of this. And again, if there is, deregulation, or if there's more heavy governance coming in, that could change the playing field as far as what happens to jobs in manufacturing, as far as what AI is allowed to be able to do inside of the manufacturing industry.
An absolutely incredible and at this point somewhat unknown future, but I can't wait to see how it turns out. Russ Bukowski, president of Mastercam, thanks for joining me on the podcast.
Appreciate your time. Thanks, Jim.
That's it for today's Industry Insights and Trends podcast, brought to you by engineering.com. If you like this program and want to keep pace with the latest innovations in engineering, subscribe to our newsletters such as Design Weekly, 3D printing, aerospace and defense, digital transformation, simulation, or a weekly roundup at engineering.com/subscribe. For our deeper engineering series, visit engineering.com TV for exclusive shows like Designing the Future, Manufacturing the Future, and the Engineering Roundtable, found exclusively on engineering.com TV. Thanks for tuning in.